All right, here are the 6, 7, and 6, 8 notes. So a trapezoid is a quadrilateral with exact one pair of parallel sides. If the legs are congruent, the trapezoid is an isosceles trapezoid. In an isosceles trapezoid, both pairs of base angles are congruent and the diagonals are congruent. So it gives you the vertices and it's asking if this is a trapezoid and determine whether it is an isosceles trapezoid. First thing I'm going to do is I'm going to do a quick little sketch over here off to the side. And again, it doesn't have to be perfect. So A is at -3, -1. B is at -1, +3. C is at 2, 3. And D is 4, -1. Okay, so quick little sketch. So now what we have to do is determine whether or not it is a trapezoid and then determine whether or not it is an isosceles trapezoid. So to determine if it's a trapezoid, we're going to find the slopes of all four sides because for it to be a trapezoid, only one pair of those sides will be parallel. So we are hoping that BC and AD are parallel and that AB and DC are not. So the slope of AB, and again, it's change in Y over change in X. So slope of AB, AB, AB. So 3 plus 1 over -1 plus 3. So that'd be 4 over 2, which is going to give me a slope of 2. Okay, and then I'm going to do the slope of BC. Change in Y over change in X. So BC would be 3 minus 3 over 2 plus 1. So that's 0 over 3, which will give me 0. I'll find the slope of AD. Change in Y over change in X. So AD, let's see, that would give me -1 plus 1 over 84 plus 3. So that would give me 0 over 7, so that's 0. And then I got to find one more, so the only other one I need to do is the slope of CD. So change in Y over change in X. So for CD, we have -1 minus 3. Change in X would be 4 minus 2. So that will give me -4 over +2, so that'll give me -2. Okay, so what I'm doing here, and we'll put the slopes over here. Slope of AB is 2. Slope of CD was -2. Slope of AD and BC are both 0. So you're just looking for this one pair right here of parallel lines. So far I know it's a trapezoid. And now what I got to figure out is if it's an isosceles trapezoid. So to figure out if it's an isosceles trapezoid, I need these two pieces here, AB and CD. I need those links to be the same. So since we're talking about links, we're going to do the distance formula. So I'm going to find the distance of AB and then the distance of CD. So x2 minus x1 squared, so that'll be 3 plus 1 squared, plus y2 minus y1, so -1 plus 3 squared. So 3 plus 1 is 4, 4 squared is 16. -1 plus 3 is 2, 2 squared is 4. So that would give me the square root of 20. So I need the distance of CD to be the square root of 20 in order for this to be an isosceles trapezoid. So again, 3 plus 1 squared plus, let's see, that would be 2 minus 4. And again, it doesn't matter if you do the x's or the y's first. It doesn't matter. It's the same thing as saying 3 plus 4 and 4 plus 3. You'll get the same answer. So that will give me 16 and 4, which will give me 20. So since those are the same links, what I can write down here is ABCD is an isosceles trapezoid. And we know that because AD is parallel to BC, and the measure of AB equals the measure of CD. Again, you can always pause this if I go too fast. Okay, we're going to assume that these are isosceles triangles. I mean, not triangles, trapezoids. So for this first one, what we know about trapezoids are that these right here, these angles on the sides, they will add up to 180 degrees. So 180 minus 125 will give me 55. And the thing about isosceles trapezoids are that the base angles are the same. So this will be 55 degrees. And again, we know it's isosceles because I told you to assume that it's isosceles. In this case, for the next one, I know it's an isosceles trapezoid because those lengths are the same. So I know my base angles are going to be the same. I don't even need to know that though because it's asking for the measure of angle L, and again, those add up to 180 degrees. So 180 minus 40 will give me 140 degrees. Okay, the last little part about a trapezoid is what is known as the mid-segment. Or the midpoint of a trapezoid. It's the segment that connects the midpoints of the legs of the trapezoid. So the formula you'll use here, it is measured to 1/2 sum of the bases. So if you look in our picture, there's a base, and then you have your leg. And it's easier to explain in the examples. So for trapezoid H, J, K, L, M and N are the midpoints of the legs. So we know this can be base 1, this can be base 2, or vice versa. It doesn't matter. If HJ is 32, so there's a base. LK is 60, there's a base. Find MN. So MN will be equal to 1/2 of the sum of those bases. So 32 plus 60, and that will give us 46. Okay, and then the last one here, HJ is 18, so there's a base. But now they give me MN. They give me this right here, which is the midpoint, or the mid segment. So we have 28 will be equal to 18. Hang on, 1/2 18 plus base 2, because that's going to be our LK. So first I multiply both sides by 2 to get rid of the 1/2. So multiply all this by 2, multiply that by 2. That gets rid of the 1/2. 2 times 28 is 56, is equal to 18 plus that second base. Subtract 18 from both sides, so 38 will be equal to the base 2. So your length of LK will be 38. And that's it for trapezoids. So the other notes are over kite, and this is the last one for this unit. So properties of kite. Kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. The diagonals of a kite are perpendicular, so we know we have a right angle in here. For this kite, MP is perpendicular RN, so we just drew that symbol here to show that. In a kite, exactly 1 pair of opposite angles is congruent. So in this case, this whole angle M is congruent to the whole angle of P. So here we go. If W, X, Y, Z is a kite, find the measure of Z. Okay, so here's what you need to know. In a kite, these opposite angles are congruent. There is 360 degrees in a quadrilateral, so if I take out the 80 and take out the 60 that is already being used, I'm left with 220 degrees. Since I know that these angles are congruent, you just divide it by 2 and you will have 110 degrees left to split evenly amongst these two angles. So the measure of angle Z would be equal to 110 degrees. Okay, the next one, if ABCD is a kite, find the length of BC. So they are wanting us to find this length right here. The thing is, I know I have a right angle, and so we can do Pythagorean theorem. So we would have a squared plus b squared is equal to c squared. Again, across from the hypotenuse is always the c. So 5 squared plus 12 squared is equal to c squared. This is actually a Pythagorean triple. So if you know it, you know it. If not, you can solve for it. C will come out to be 13. So when it's asking for BC, BC would be equal to 13. Okay, and then the last little example here. If GHJK is a kite, find each measure. So find the measure of JRK. Well, we know the diagonals are perpendicular, so I know this is going to be a right angle. So that's going to give me 90 degrees. If RJ is 3 and RK is 10, find JK. So again, I'll just draw a quick little picture in here. Here's my right angle. It says RJ is 3, so that's this piece. RK is 10, that's this piece. Find JK, so there's X. Pythagorean theorem. So we would have, and I could do it over here off to the side. A squared plus B squared equals C squared. I'm looking for the hypotenuse, so 3 squared plus 10 squared is equal to C squared. So that's 9 plus a 100 is equal to C squared. So 109 is equal to C squared. Square root both sides, so C is equal to 100, or sorry, the square root of 109. So C equals, or sorry, JK will be equal to square root of 109. Find the measure of, or sorry, if the measure of GHJ is 90, so we're talking about this up here, GHJ is 90, GKJ, so this down here is 110. Find the measure of HGK. So again, we know that these angles in here are congruent. So we'll just do like we did last time. We had 360 degrees in a quadrilateral. You take out the 90 and you take out the 110 that's being used. What you have left over is 160 degrees. You split that evenly amongst the two remaining angles and you will get 80 degrees. And that will be equal to the measure of angle HGK. HJ is 7, find HG. Those two pieces are congruent, so HG is going to be equal to 7. HG is 7, GR is 5, so again I'm going to have to draw like a little triangle here, right triangle. HG is 7 and GR is 5, so A squared plus B squared equals C squared. So we will have 5 squared plus B squared is equal to 7 squared. So 25 plus B squared equals 49. When I subtract, we'll get B squared is equal to 49 minus 25 is 24. And then square root both sides. So I got to do my little family tree here. 4 and 6, 2 and 2, 2 times 3. So B is equal to the square root of 2 times 2 times 2 times 3. Pull out the pair, so B is equal to 2 square roots of 6. And I'm looking for HR, which is the length of B, so HR is 2 square roots of 6. And that is it for kites.